This is the lecture for lesson 32. The first part of this section is going to look at applications around compound and continuous compound interest, but now we're going to solve for variables that aren't the new balance. So for review here, our compound interest formula A equals P times the quantity 1 plus r over n to the nt power was for P is the initial principal invested, R was the rate for T years, and N was how many times it was compounded in a year. And then continuous compound interest was the PE to the RT, where P again is principal, R again is rate, and for T years. So we could find the balance. So now we are going to solve for T. We may solve for R as well. Kevin invests $400 in an account that compounds interest monthly and earns 4%. How long will it take him to have $470 in the account? Round your answer to the nearest year. So this is A equals P, 1 plus R over N to the NT power. So the amount he has accrued is $470. The initial amount invested was $400. 1 plus the rate is 4%, so 0.04. It is compounded monthly, so that makes the N 12. And then that means 12, and then it says we're solving for T, so T is going to be our variable. All right, so what we're going to do first is divide both sides by that 400. So I get 1.175 equals 1 plus 0.04 over 12 to the 12t power. Now, I have an exponential piece on this side. So what I'm going to need to do is I need to log both sides. And it doesn't matter if you use basic log, common log, or natural log. Either one is going to work. So if I log the side and I log the other side, 1 plus 0.04 over 12 to the 12t. We are then able to bring this power down front. So I have log of 1.175 equals 12t times log of 1 plus 0.04 over 12. And I'm leaving everything in its form right now because if I round this too soon, it's going to throw off my answers. Okay, our goal is to get t by itself. So the next thing I'm going to do is going to get rid of this log of 1 plus 0.04 over 12. 1 plus 0.04 over 12. So I now have log of 1.175 over log of 1 plus 0.04 over 12 equals 12t. So what I'm going to do is I'm going to get this answer in my calculator. I'm going to take that answer and immediately divide by 12. And you should end up with, if we round to the nearest year, 4 years. I will show you what this looks like on the next slide in my Desmos. Okay, so in my Desmos here, you can see that I took log of 1.175 divided by log of the quantity 1 plus 0.04 over 12. I hit enter. And then what I did was I highlighted this. I'm on a PC, so I hit Control C. That copied it. I immediately pasted it down here with Control V shortcut and then hit divided by 12. And that gave me 4.038, which the closest year that rounds to is 4 years. Number 2, Carly invests $17,000 in an account that compounds interest weekly and earns 6%. How long will it take for her money to double? All right. Well, if she has 17,000 currently, double that is $34,000. So the amount in the account will be 34,000. She currently has 17,000. 1 plus the rate is 6%, so 0.06. Now this is weekly, and weekly we use 52. There are 52 weeks in a year, and my power is going to be 52t. So whatever's dividing by your rate here is immediately what is put into your exponent as well. So the first thing I'm going to do is divide by that initial amount here of 17,000. And I will get 2 equals the quantity 1 plus 0.06 over 52 to the 52t. So what I will now do is I need to log both sides in order to bring this exponent down. So if I take the log of this side, 2 equals the log of this side, 1 plus 0.06 over 52 to the 52t. I can now bring that 52t power down front. So I have log of 2 equals 52t times log of the quantity 1 plus 0.06 over 52. Which means I can divide by that entire quantity here of the log 1 plus 0.06 over 52. So I get log of 2 over log of that quantity, 1 plus 0.06 over 52, equals 52t. So I'm going to type this entire thing into my calculator first. I will copy that answer and then immediately divide by 52. And for this one, I end up with about 11.6. So going to the nearest year is going to round up to 12 years. And again, I will show you how I do this on Desmos on the next slide. All right, so you can see I took the log 2 divided by log of the quantity 1 plus 0.06 over 52. I highlighted this entire answer. I hit Control Copy, Control Paste, and I immediately divided that answer by 52. And I got 11.559. That's 11.6. That is going to round up to 12 years. Number 3, Patrick invests $12,000 in an account that compounds interest monthly that earns 4.5%. How long will it take for his money to triple? Now, the one we just did was it doubled, and we put the doubled amount and divided and ended up with the 2. So there is a shortcut here that you could say we want to have triple the amount of money to what we started with. 1 plus your rate is 0.045. Remember, every percent has to be divided by 100 to get the decimal form to go in the equation. And we are doing this monthly, so that's a 12 to the 12t. So instead of going 36,000 equals 12,000 and then doing that divide by 12,000 to get the 3 here, I can just know that, hey, if I'm tripling, that's going to be a 3 here. So I save myself just a little bit of time. So I'm going to log both sides because I need to bring that power down. So log this side, 1 plus 0.045 over 12 to the 12t. So that 12t is going to come down front. Log of 3 equals 12t times log of 1 plus 0.045 over 12. We'll then divide by the log piece, just like we've been doing. So I get log of 3 over log 1 plus 0.045 over 12 equals 12t. I'm going to get this entire answer and take that and divide by 12. When I do that in Desmos, I got 24.459. So the closest year, if I'm looking at the whole number, is actually going to be to round down to 24 years. So I'll show you that on the next slide. As you can see, I took log of 3 divided by log of the quantity 1 plus 0.045 over 12 and got this number 293.51224. Again, I don't want to round it because if I round too soon, my final answer is not going to round correctly and it's going to tell me it's wrong. So I'm going to copy this whole value divided by 12 and I get 24.459. 24.4 is not enough to round up. If I'm looking at that whole number, it's not going to round up. It's going to round down to 24 years. Katie invested $4,000 in an account earning 3.25% annual interest that is compounded continuously. So that means we're now on to the second equation, A equals PE to the RT. How long will it take for her to have $5,500 in an account if there are no other deposits? And round your answer to the nearest year. So she wants to have $5,500. She currently has $4,000. We have E. R is 3.25, so 0.0325. And again, we're still solving for T. So T is still my variable. First thing I'm going to do is divide by that initial value, 4,000. If I take 5,500 divided by 4,000, I get 1.375 equals E to the 0.0325t. Now, we have an E exponential. So for this one, I should use natural log to make sure that I'm canceling out the E. So natural log 1.375 equals natural log E to the 0.0325t. Once we log both sides, the power comes down front. So natural log 1.375 equals 0.0325t times the natural log of E. Well, that works out really nice because the natural log of E is just 1, and that cancels out. So all I have left to do to solve for t is to divide by 0.0325. So if I take natural log of 1.375 divided by 0.0325 in a calculator, I get 9.799 roughly. The decimal keeps going. So I'm going to round that up to 10 years. Again, just showing you how I put this in Desmos. The natural log of 1.375 divided by 0.0325 is 9.79, which means that is going to round up to 10 years, which is where I got my answer for the previous problem. Paul hopes that a $7,500 investment will be worth $11,000 in 8 years. If the interest compounds continuously, approximately what rate of growth will he need to achieve that goal? Express your rate as a percent rounded to one decimal place. All right, so we want $11,000 and he currently has $7,500. We do not know the R this time, but we know T is 8. So the first thing I'm going to do is, again, divide by my initial amount here. Now, if I do this, it doesn't give me a nice decimal. All the other ones I've done have given me a nice round decimal that I could write. So for this one, I'm just going to leave it in reduced fraction form. I have done that in Desmos, and I'll show you on the slide in a minute here, where you can turn it into a reduced fraction. So 11,000 divided by 7,500 reduces to 22 over 15 is going to equal E. And I'm going to flip this 8R. I always like to put the number in front. So I am to the point now where I can log both sides. Again, I'm going to use a natural log though, because we have an E. So if I natural log the side here, E to the 8R, when I bring that 8R down in front, 8R times the natural log of E, which we know the natural log of E is 1, so it just drops off. So I now have the natural log of 22 over 15 equals 8R. And I'm going to divide everything through by R to get my decimal here. So what I do is I get 0.0479, and we need to turn this back into a percent. So if I times by 100, that's going to make it 4.79%, but it wants us to round to one decimal place. So that is 4.8%. On the next slide, again, I'll show you my Desmos so you can see my calculations. So when I first went to do that 11,000 divided by 7,500, it gave me this long decimal here. And I know that with these problems, if I start with a rounded decimal too soon, it's going to make the answer incorrect at the end. So in Desmos, there's this little button on the side here that if you're getting a decimal, you can click it and it will give you the reduced fraction form. So that's how I got that 22 out of 15. So when it came down to then taking the natural log of 22 over 15, put that in parentheses, take that whole result divided by 8. This is where I got that 0.047, and then I wrote a 9 because the 7 is going to round the 8 up to a 9. And then we went from there to get our final answer of 4.8%. Kristen has $9,000 in an account earning 5.75% annual interest that is compounded continuously. How long will it take for her money to double? Well, we know double is going to be $18,000 compared to her $9,000. E to the rate 0.0575t. Again, how am I getting that? Take 5.75 divided by 100. Now, if you remember the short version, if you divide this, you're going to end up with 2 equals E to the 0.0575t because we want double the amount of money. So the double the amount, and I just need E to the RT. So now I'm going to natural log both sides. .0575t, so that I can bring my power down front. So natural log 2 equals 0.0575t times the natural log of E, which we know that cancels out to 1, so I don't need it there anymore. So I have natural log of 2 equals 0.0575t. So if I want to solve for t, I'm going to divide by 0.0575. So natural log of 2 divided by 0.0575 gives me the answer of 12.05. So that's going to round the closest year is 12 years. This here is just a quick screenshot of my natural log 2 divided by 0.0575, how I got that 12.05, rounded to my 12 years. The last part of this section is going to just look at some other exponential and log functions like growth and decay. In 2000, the population of Africa was 643 million, and by 2016, it had grown to 906 million. Use the exponential growth model A equals AO e to the kt, in which t is the number of years after 2000 to find the exponential growth function that models data. Well, we have our AO is 643. That's our initial amount of people. And we're going to need to find our K. And we can find that by using the value that we have for 2016. So we know there were 906 million from our 643 million. E to the K, we need to solve for K from 2000 to 2016. That's 16 years later. So if I start with dividing by the 643, which we know we've done this multiple times now, this one's not going to come out nicely. It's going to be a decimal. So what I'm going to do is I'm going to write it as a simplified fraction. So it doesn't actually reduce, so we're just going to leave it as 906 over 643 equals e to the 16k. So we know that we can solve for this by natural logging both sides. So I'll have the natural log of 906 over 643 equals, I'll bring that 16 down, 16k times the natural log of e, which we know natural log of e is just 1. So we can solve for k by then dividing by 16. So I'm going to take the natural log of 906 over 643. I'm going to get that answer, copy it, and then divide by 16. So what you should get is k equals 0.021 if I go to 3 decimal places. That means my equation is now a equals 643, my initial amount of people, e to the 0.021 times, t. So we can now predict the amount of people in any year after the year 2000. Now, for B, they want us to figure out the when to solve for T. Does that value of the population reach 960 million? So for B, they want to know when do we hit 960 million? So 943E 0.021 T. So we'll do those same steps again. Divide by the initial value, 643. This is not going to reduce, so I'm going to leave it in fraction form. Now I'm going to natural log both sides. So if I natural log both sides, this 0.021t is going to come down front, times by the natural log of e, which we know the natural log of e is just 1, so it drops away. That means that our last step is to just divide by 0.021. So if I go to my scientific calculator again, natural log of 960 over 643, all divided by 0.021 is going to give me a t value of 19. Now we need to remember that t is the number of years since 2000. So the year that this will happen is 2019. As you can see, here are my calculations for the previous problem and how I got my answer for the K value of 0.021. And then for B, how we got our answer of 19 years. An artifact originally had 16 grams of carbon-12 present. The decay model, A equals 16e to the negative 0.0000121 t, describes the amount of carbon 12 present after t years. How many grams of carbon 12 will be present in 5,820 years? So the first thing we need to realize is that this is a decay problem because the rate, or what's in my exponent, is negative. All the other problems we've worked with have had positive exponents and they made the number get larger. So in a decay model, the number is going to get smaller. So for this, we just have to figure out what the answer is when we plug in 5,820 for t. So 16e to the negative 0.000121 is going to be times by 5,820. And you're just going to go into your scientific calculator. You can type that exactly as is. 16e, raise it to the power, and you should come up with 7.9119, and my units are grams. I know I did it right because the value should have gone down when you see that word decay. So we're talking about a half-life here, and this next question just says, what is the half-life? What does that mean? Well, a half-life is the amount of time for half of a material to decay. So another way to think of this is when you take medication, there is a half-life, and they specify that, and that determines how frequently you take your dose. And that keeps a steady dose in your bloodstream. So anytime you're working with half-life, that is going to be the amount of time it takes for the material to reach half of its original amount. So when doing this in Desmos, you just want to make sure when you have two pieces being multiplied in the exponent that you put parentheses around it, just to make sure that that whole value stays up in the exponent so that you can get the correct answer. A Richter scale is used to measure the intensity of an earthquake. Given the formula R equals log of I over IO, where R is the magnitude and IO equals 1 for the minimum intensity, find the intensity of an earthquake with a magnitude of R equals 6.5 and round your answer to the nearest whole number. So what they're wanting us to do is I sub O is 1 and R is 6.5. So 6.5 equals log of I divided by 1, which is just log of I. So 6.5 equals log of I. Now this is a common log of base 10. So that means we have a base of 10, an answer of I, and an exponent of 6.5. So that means 10 to the 6.5 equals I. And then all I need to do is go to a calculator and type 10 to the 6.5 power, and you will get 3,162,278. That is the end of this section. This is also the end of this module. So make sure all of your homework is complete, and we'll get ready to do your quiz in our next class.